So today we are going to start a new unit. This is unit number 3, electric circuits. So we are going to look onto current. We are going to talk about resistors. We are going to talk about circuits, introduction to some new kind of circuits which you haven't solved before. So the very first question we should ask ourselves before starting this, what powers are city or like what powers are home exactly? What is that power and how we are using that power? Basically, everything about it we should ask, like from the scrap. So, we are going to answer this question after this lecture, like what actually
Mm,
powers are place, and we're going to talk everything about the physics of that concept.
mhm,
So, these are going to be the topics of today's lecture. We're going to talk about what is the formula of current, how it is defined. Then we are going to relate that current with the potential, like what is potential. Then we're going to talk about resistance and how it can be varied with temperature as well. Now, last but not the least, the ways of solving some circuits using some laws. This is completely new. Kirchhoff's current law. This is the name. And KVL is Kirchhoff's voltage law.
mhm,
And there's other methods as well to solve some other type of circuits. So we're going to talk about these things. Let's start from the very basic thing, like what is current? So current is basically defined as charge per unit time, or we can call current as rate of change of charge. Now we are very clear about what is charge, how it works, what are the forces act for the charges. We have done all such questions in the previous units. So we are very well
mhm,
aware about charge. So current is simply rate of change of charge, or you can say dq by dt. Now what this dq by dt thing is, the dq, or you can say d by dt thing is all about differentiation. Sometimes we'll be having such equation of current because of its alternating nature, which are going to be solved using differentiation only in order to find the current from it. So for such
mhm,
equations, we'll be using them, although the basic formula for current will always be like you can say average current is always be charge per unit time. Like what amount of charge is being flowing in a given time.
mhm,
Next we have is Ohm's law. We have seen Ohm's law before, like in earlier grades, but here we are
mhm,
going to talk in a little more depth about Ohm's law and all the things related to the Ohm's law. So if you want to learn Ohm's law, let us consider a conductor. So we are also aware of all the properties of the conductor as of now because we have seen capacitors in the previous class and some other things about conductors in the previous class. So we are assuming that we have a conductor and it is at a given temperature. So there must be some fixed temperature, no variation in temperature.
mhm,
So in such conductors, what we found is that whatever current flows through it, I, is directly proportional to the potential difference of the battery applied. So I is something which is directly proportional to potential of the conductor or the points. We can
mhm,
also write this equation as that potential is something which is directly proportional to the current. Like whatever value of potential we put as a battery, that value of potential will be directly proportional to the current flowing into the circuit through that conductor. When we remove this proportionality thing, we came to know a very new thing about conductor, that conductors have some sort of constant in them which resist the flow of charge. That resist is known as resistance. So we call this coefficient of proportionality as resistance. Resistance is something which is the basic property of matter. Like every matter in this around us have some sort of resistance, and it is
Mhm.
something we call opposition to the flow of charge. So in every conductor, like whatever conductor it is, it might possess some sort of resistance to the current. So the SI unit of measuring this resistance is nothing but ohm, based on the name of the scientist, ohms.
Mhm.
Also, if we want to define 1 ohm, so 1 ohm is nothing but 1 volt by 1 ampere. So I can also be written as V by R.
Mhm.
Similarly, R can also be written as V by I.
Mhm.
We have different relations from this one relation only. So we are going to use these relations in the numericals in today's class as well. Now, another thing. So in the previous classes, we defined conductors on the basis of presence of free electrons. And this presence of free electrons will also decide that conductors can be categorized into two categories. One is ohmic conductors and another is non-ohmic conductors. So ohmic conductors are those conductors which follows Ohm's law to a greater extent, like which follows Ohm's law completely. Now, what does it mean? Let us understand it. So according to Ohm's law, V is directly proportional to I. So V is nothing but R times current.
Mhm.
So if we try to draw a graph between V and I, we'll find that according to the Ohm's law, a graph should the graph of a conductor should look like this. So ohmic conductors are those conductors whose VI characteristic curve look like this. And for those conductors whose VI characteristic curve doesn't look like this are something called non-ohmic conductors, which do not follow Ohm's law completely. Like they do follow to till some extent, but not completely. But ohmic conductors are something which follow completely, like 100% of Ohm's law. That is
Mhm.
something which is not possible. So this is how we categorize different type of conductors on the basis of Ohm's law. Now this is some sort of knowledge more than a question. So here the question says, what is the resistance of discharge tube? Now the discharge tube is nothing but a tube which is created in such a way that inside the tube there is vacuum, like
Mhm.
not even air. So that is something we call discharge tube. So when we found a discharge tube's resistance, we found that it is non-ohmic. So it is
Mhm.
a characteristic of discharge tube, which might be asked in some sort of MCQ. So you can just
Mhm.
learn it. Next, to keep this graph in mind, then whenever we are talking about VI curve, a straight line is obtained. This straight line is also explaining one more aspect of the conductor. That is, its
Mhm.
slope is equals to resistance. So if the graph for a conductor is going upward, it means positive resistance.
Mhm.
If the graph of the conductor is going somewhat like this,
Mhm.
it means negative resistance.
Then it
And
would
some
be
materials
C.
also say that the graph of the resistance, graph of some materials, like VI curve of some materials, look like this, a line parallel to current. So this means that resistance is not variable. Like it is a constant resistance, it doesn't depend upon certain properties, so it won't change over time.
Mhm.
So
So it's
what
opposite
would you
B
say about the question?
is like CD is a negative resistance.
Yes. So sometimes a question can be asked from the reference of a graph also. Now let's talk about resistance in a little detail. Like if it is a quantity, so it must depend upon certain factors. If we can understand that how those factors affects the resistance of a conductor, we might able to calculate the resistance of any kind of conductor. So
Mhm.
we saw that resistance is something which depends upon the conductor's dimensions. Like suppose this is a conductor and this
Mhm.
conductor has certain area as well as it might have certain length. So its resistance based upon its dimensions can be given by this formula.
Mhm.
Or we can say that the resistance is something which is directly proportional to the length of the conductor and inversely proportional to the area. So when we combine these two equations, we got nothing but R is equals to rho L by A, where this rho is resistivity. Again, it is a property which might change with temperature. So if temperature changes, sometimes resistivity of a conductor also changes, and it can
Mhm.
ultimately affect its resistance. So
Mhm.
conductors are something whose resistance are temperature dependent, and that temperature dependence is arise due to this resistivity thing, which is there in the resistance only, which is a constant factor of every material or every conductor. Like every element has different resistivity. It is constant thing, and it is there with them. You haven't
Mhm.
induced it. That's what make it different on
Mhm.
microscopic level. So we will try to calculate the resistance of different material using this relation and some variation. So there is a question for you based upon that relation only. Remember it. Rho L by A. Can you think over it?
Mhm. So like it's um R equals to like you would write 4I over 3A. I don't know how to solve it though.
All right, let us understand. So there is a wire of resistance R which has length L and area A. Remember these things. So I'm assuming that this is some wire. Let's call it wire A. It has some length L and some area A. Its resistance is R. This is what it is given.
Mm-hmm.
So the question asks, what is the resistance if length becomes 4 times, area becomes 3 times? So what we can say that for such questions, the one thing which is constant, because we are considering that one element only, so its resistivity is something which is constant.
Mm-hmm.
So for two different wires, we can swap it exactly. So it will help us to solve the equation, like equate the equation. So here R is nothing but rho L by A. This is the initial R. Now what we did is we increase the length and area by the following condition, like length becomes 4L and area becomes 3A. So rho R final will become, like length is become 4 times
Mm-hmm.
and area has become 3 times. So here we can see that 4 by 3 rho L by A. So can I write R final is nothing but 4 by 3 R initial? Like to the initial value, it become 4 by 3 times.
Mm-hmm.
This is what it is asked in the question to find that how its resistance changes. So it will become 4 by 3 times
Mm-hmm.
or fourth time. Another question. Now I guess you can try this completely same.
So the length would be 2L and um is it just like the Ri equals to 2L? Like
Yeah, something like that, but just see that how exactly change happens. The question says that a wire which has a resistance R is stretched to double its length. Like initially, this was the wire, it has some length L. We
mm-hmm.
stretched it and it becomes twice of its length, like
Mm-hmm.
2 of L. So the area thing, it must be changed now. The initial area, whatever it has,
Mm-hmm. The
the
area would
final area, yeah, the area would have decreased. So like by what factor the area would have decreased and by what factor the resistance has changed. That is what we have to find here. So what we can do is initial resistance was rho L by A as it is. Final resistance will be rho. In place of L we'll write 2L, but in place of area we have to find what it is. So how can we find it? We can find it using volume conservation. Like whenever we are stretching or changing the shape of something, the volume conservation must have been there. Like the
mm-hmm.
volume has changed, volume must not change, only the dimensions has changed. So initial volume in terms of length and area must be equals to in terms of volume in terms of length and area. So initially it was AL, final will become twice of L, A
Mm-hmm.
final. So A final would come out as A initial by 2.
Mm-hmm.
So you can simply substitute the value here. So R final becomes rho 2L by A by 2. So it will be 4 rho L by A. So R final would be 4 times the R initial.
Mm-hmm.
This is what we have to find here. So basically, the question wants us to explain that if the length of the conductor increases, so its resistance would increase by 4 times. So it is better to use thick wires to reduce the energy losses. So this
Mm-hmm.
question also explains this. Now again, a same question, you can try it out as a part of your homework. Some more questions based on resistance only.
Mm-hmm.
Like, one second. So again, a similar question, but from a different perspective to solve. Like resistance is nothing but rho L by A. Rho is something which is constant. So L is the length which is given here. So we can write L. But in place of area, we have to write the area. So what is the area of this face of the cuboid or whatever wire structure you find it?
Mm,
What is the area of that face?
H times B.
Yes, it's H times B. So rho L by HB. That is the resistance of this wire or conductor. Similarly, this area must be pi r square. So resistance
Mm-hmm.
would be rho L by pi r square.
Okay.
You can try it as a part of your homework. So I have kept so many questions in this PPT.
Yeah.
Like it's a lot big. What we are going to do is that you must have some questions to practice while revising the things. So it will
Mm-hmm.
help. And if you find any difficulty, you might ask me.
Mm-hmm.
So again, similar question based upon different way of solving, like actually exactly putting value here. It so length is given 15 meters and resistance is given 5 ohms. Area is given this much. And the question asks what is the coefficient of resistivity? Like what is rho? So rho would be RA by L. So if you substitute the values of everything given in the question, you'll get the value of rho and you can find the correct option.
Mm-hmm.
Next, let's talk about EMF and potential difference. So EMF is something which we have already seen, and we also discussed about how battery works, what it contains, electrodes and all. So whenever we are using a battery, it must have two plates. Like we learned that one is cathode, another is anode. One loses charge, another gains charge. This is what exactly happens between the plates. But here, when we are writing that this battery has a 5-volt potential, what does it exactly means in terms of physics? So it is supposed to set that the bigger plate, which is supposed to be positive in nature, initially has 5 volt of potential, and this plate, which is negative in nature, initially had 0 volt. So the difference between these two plates, like if I assume it as A, it has B, the difference between B and A is nothing but 40 volts. So at any instant of working of this battery, we find that the potential difference between these two plates will always remains 40 volts.
Mm-hmm.
But there comes a time when the potential becomes equal for both of them, like what happens is this 5 volts will slowly get transferred to this B plate and its potential starts rising and its potential starts decreasing. So every time you subtract two numbers, you'll get 5. But there comes a situation when both the numbers become 2.5 volt and 2.5 volt.
Mm-hmm.
So in that case, the potential difference becomes zero, and this is the situation when we felt that our battery died.
Mm-hmm.
So this is what exactly happens between the plates and how the potential variation takes place. So whichever force which acts between the plates, the force which acts on the charges, something called EMF, like electromotive force. So basically a force which acts on the conductors, like
Mm-hmm.
on act on the charge when they are moving across the circuit.
Mm-hmm.
So EMF or potential difference is nothing but same almost. So sometimes the examiner asks or just write in the question that EMF is the EMF of the battery is 5 volts, and sometimes it will use the same word. It will use a different word for the same meaning, like the potential difference between the terminals of the battery is 10 volts. So both the things means almost same. Some theoretical thing
Mm-hmm.
is there, but technically both are completely same. So we are going to talk about that also in some questions. Although the working is same, just remember that how these things work or what exactly happens. For every battery, what we have encountered is that most of the batteries potential difference reduces like very quickly. Like initially the potential difference was 5 volt, but it is dropping like very quickly to zero in no time. How is it possible? It might be possible because of the internal resistance of the battery. So that internal resistance is something which is considered to be there with the battery connected in series. So this whole thing, or you can say the whole diagram is something which is representing battery in the circuit.
Mm-hmm.
So whenever we are going to draw a battery in the circuit, we are going to use this symbol. One plate is positive, one is negative, and it is something which is represented by smaller because it is not of that much greater magnitude or something. It is simply a small resistance which is actually using the energy of the battery.
Mm-hmm.
Although we have considered that the resistance, or you can say the property of this thing, is similar to what is there in conductors. Here comes the Kirchhoff's current law. So as I said, there will be some different types of circuits. There are some laws to solve them, to operate them, or you can say to run multiple things from the same structure, like from the same source, in a way that energy is driving equally everywhere. So how these laws are operated and what are these laws? So basically there are two laws. One is Kirchhoff's current law, also known as KCL. The law simply says Like suppose if there is a junction of wires, like there are three, four wires, and they all are meeting at this point.
Mm-hmm.
So suppose two wires were supposed to carrying a current to the junction, while three wires are taking from it. So the law says that whatever current came to the junction is always equals to the current went away from the junction. Like I1 plus I2 is something which is always equals to I3 plus I4 plus I5. So this is something like current came into the circuit and equals to current out. So whenever we are solving this incoming plus outgoing current sort of thing, so they are always equal in number. So whenever we subtract them or we find the actual thing flowing in the circuit is zero. So this law also says that algebraic sum of all type of currents, like which is coming into the circuit and out of the circuit, is
Mm-hmm.
zero. So this is what Kirchhoff's current law says. A very basic thing, like it is very supposed to be. You can also explain yourself this particular phenomena by assuming that there is a junction of pipes in which water flows, through which the water flows. So if the two openings of the pipe is throwing water into the junction, other three must have been putting it out of the junction in case of water. Same goes with the current as well. This is how they
Mm-hmm.
are operating. The next we have is KVL, Kirchhoff's voltage law. So this law says that the algebraic sum of EMFs, now EMFs or battery means same,
Mm-hmm.
or potential difference. So sum of EMFs or potential difference around a closed circuit is zero. So this is the revolutionizing law, and it has almost changed the dynamics of the circuits of every industry. Like it wasn't there before, and when we got it, so we are able to scale up a lot in terms of energy. We just have to make a closed circuit. Like in whichever way we are able to close the circuit, it will be good for us.
Mm-hmm.
So it says the sum of EMF, or you can say potential, plus sum of all the IRs is zero. Now it includes negative value. Otherwise, it won't be zero. It must have include negative values. Otherwise, the equation would not have to be zero. Now, how we are supposed to apply this equation in the question? It will completely depend upon the circuit. Although the basic thing which you can remember or learn is in the circuit when we are writing the equation, so we must name a loop, like for which loop we are actually writing this equation.
Mm-hmm.
The loop is generally named in terms of A, B, C, D, A. What does it mean? That first you went from A to B, then B to C, then C to D, and then again you came back to A. So it must be a
Mm,
closed circuit like this. A, B, C, D. So I'm starting the circuit, like reading it from here onwards.
mhm,
A to B, B to C, C to D, then D to A. So now assume that there is a resistor, there is a battery, there is another battery, there is another resistor.
mhm,
This is V1, this is R1, this is V2, this is R2. We want to write the equation for this loop. How we are going to write it? Just remember this thing, or just remember V is nothing but IR. So I'm supposed to read it from A to B first, right?
mhm,
So from A to B there is a battery. So I must write its potential. So whenever you are reading the circuit, like you are going from A to B, and you encounter that at last there is negative plate, there is positive plate.
mhm,
So I'm supposed to write positive V1 here. From B to C, I can see that current is also flowing from this direction, and I'm also reading the circuit from this direction, like from B to C only. So
mhm,
I'll write equals to I small r1. IR, I have to write IR always. Now,
mhm,
similarly, we are reading from C to D. You came out again from the positive side of the battery. So it would be plus V2 once again. If it is negative, if you're meeting the negative plate, it would be negative V2. And
mhm.
similarly, again, the current is going through this way. So I'll write I plus R2. So this is how the equation is supposed to be written. It's a different thing. We might see some questions based on it, and we'll be able to learn it that way also.
Mhm.
So let us try some questions based on that thing only. And this is something circuit in which you just try and find out like which battery is charging and which is discharging. Like find it out.
Mhm. Are all of them not charging?
First of all, tell me how many batteries are there.
Um, 3.
Three. Absolutely wrong. Only two. This is resistance which is there in the third row. This is not a battery. So remember the symbols first. This is battery having a small resistor, and this is a general resistor, and this is a cell which doesn't has any internal resistance. So this
Mhm.
is how we are supposed to write them in the circuit as well. So the question says find the current through 10 ohm resistance in the network shown in the figure. So that what is the value of this current? This is what we have to find here. So again, remember in this class we are going to solve so many numericals based upon Ohm's law, and this is one such numerical. So remember the relation V is equals to IR. This is always applicable everywhere in a circuit. So we have to find this I. First of all, we just read Kirchhoff's current law, which says if there is current coming from the batteries, they must be going through this, and the I current is something which is because of this I1 and I2 coming out of
Mhm.
the two batteries. Then this I returns to the battery or to its source. Always we have to form, always we have to take the current in such a way that whatever amount of current you have taken out from the battery, it must return to it. If it is not able to return back, then it simply says that your circuit is wrong or you have considered wrong things.
Mm-hmm.
So if I came out of it, I must go into it. So here, what we can do is we can assume these two batteries as a single battery. And that single battery must have some E net and must have some R net. Now, how that E net or the net EMF or the net resistance, internal resistance can be calculated? This is something we need to learn. So whenever we are talking about resistance, it follows its traditional way. Like in series, the net resistance is R1 plus R2, as we already know this thing, right? And in parallel, the R net is supposed to be 1 by R1 plus 1 by R2. So this is how the resistance is calculated from this battery thing. Like I guess
Mm-hmm.
there are some doubts in your mind, but you are not able to ask me. Like you don't know how to ask them. We got resistance as R1 plus R2 in series, and in parallel it should be as 1 upon R1 plus 1 upon R2. But what about EMF? EMF is something which not written in that way. There must be some different effective EMF, and that is something E1 R2 plus E2 R1 by R1 plus R2. Whereas in parallel combination, the effective resistance can also be written as R1 R2 by R1 plus R2. So
Mm-hmm.
initially we had two batteries connected in parallel thing, and finally we replaced these two batteries by single battery, and that single battery has something E effective and R effective. So that E effective is calculated by this relation, and that R effective is calculated by the given below relation.
Mm-hmm.
So we are going to see some questions based on that also. It will be more clear. Yeah, so basically that was the question. So what we can do is we can find out E effective and R effective from this particular question first, and then
Mm-hmm.
find out the answer. All right, then let us calculate it here only. 10, 5, 2, 1. That is E1, E2, R1, R2. E effective would be E1 is 10, R2 is 1.
Mm-hmm.
E2 is 5, R1 is 2. Divided by 2 plus 1. So 10 plus 10 by 3, that is 20 by 3. It is E effective. And R effective is going to be 2 into 1 by 1 plus 2, that is 2 by 3. Now we'll simply apply the Ohm's law and we'll find out the current passing through that 10 ohm resistor. Now again, the circuit would look like this when we have the final appearance. So this was just that 10 ohm resistor, that 10 ohm resistor, which is connected to this effective battery, and we'll apply the Ohm's law, which is V is equals to IR. So I is V by R, where V is this V effective 20 by 3, and R is this plus this, R effective plus this 10 ohm. So 10 plus 2 by 3. 10 plus 2 by 3. If we solve it, we'll get I as 20 by 3 into 3 by 22. 32, 32 by 3. So we'll cancel out this. 10 by 16, 5 by 8. So current is going to be what? 5 by 8 ampere. Did you understand it?
Yeah.
Just remember these two relations in case we have two batteries. In case we have two batteries.
Mm-hmm.
So this is somewhat last topic of the lecture. But this topic has a lot of questions, and we'll be having a bunch of questions as a homework. So resistance are connected in the circuit in two ways. Like one is series combination and the other is parallel combination. Series
Mm-hmm.
combination is something where it look like this. Where in parallel combination they're supposed to be connected this way. But here one after the another.
Mm-hmm.
So in series combination we can find out the value of resistance and it is nothing but R is R1 plus R2. Now how we actually got it is through Ohm's law again. We are using Ohm's law everywhere, as I told you in the beginning only. So how you can find it out, like find this relation, how it can be derived. Suppose these are three resistors connected in series with a battery of V volts.
Mm-hmm.
So in series combination, there is that one thing, like here current remains constant, but potential is something which divides. But in parallel, it's different. Current divides, like if it comes from here, it has three ways to go. So it will go accordingly. So it will divide. Whatever value of current came, it must be divided into three parts.
Mm-hmm.
And potential remains constant for all of them. But in series, it's different. So there must be some potential drop. There must be some potential drop. There must be some potential drop, which is V1, V2, and V3. So that V can be written as V1 plus V2 plus V3. We'll apply Ohm's law again. And what does Ohm's law says? That V is nothing but IR. So can I write V net is equals to I R net? Why I have written I here? Because current is something which is constant in series.
Mm-hmm.
Plus, I would say is equals to. So I write the value of V net. Like this is V and it is something V net is equals to I R net, which is equals to I R1 plus I R2 plus I R3.
Mm-hmm.
So when you solve this equation and cancel out that I thing, you'll get R in series is nothing but R1 plus R2 plus R3. That is its value in series.
Mm-hmm.
And here this R is nothing but R1 R2 by R1 plus R2, which we saw in the previous question. So it can also be derived from that way only. So let's do some problems. So which of the following are in series? So the answer would be that R1, R2, R3, they all are in series.
Mm-hmm.
Like next, what who are in series? Like whenever there is a junction, it
So
simply
like
means
R2, R4, R5.
one again.
Like R2, R4, and R5 are in series.
No, that's what I'm saying. If there is a junction, so all the wire crossing the junction would be in parallel combination. So here
Mm.
we would say that R1, R2 are in series, R4, R5 in series,
Oh,
and R3 is again
R-
different.
oh, oh, okay, yeah,
Why?
yeah.
Why? Because there is a junction.
Mm-hmm.
In the last part, there was no junction, so that's
Yeah.
why we said that all of them are in series.
Okay.
Then came the parallel combination, and remember the relation 1 upon Rp is nothing but 1 upon R1 plus 1 upon R2. And Rp, or you can say resistance in parallel combination is something product of resistance upon sum. So these are some direct results which you can learn. Like if there are some n number of resistors in series, so the net resistance is nothing but n times R. If there are n number of resistors connected in parallel combination, then the net resistance would be R by N. So you can simply find here that in series combination, resistance increases,
Mm-hmm.
whereas in parallel combination, resistance decreases. And that is the reason why R ohms has parallel circuit connections. Do you know that R ohm follows that thing only? Like all the circuits are like very separated from each other. Like they are parallel completely. So if one particular circuit stops working, it won't affect the working of any other circuit, like for any other switch, because they are
Mm-hmm.
parallel.
Mm-hmm.
This is the direct result. For capacitors also the same. You can learn.
But if the circuits were like in a series, then it would affect, right?
Like if the circuits were in form of
If they were
series.
in like, can they be in a
Yeah.
series? Yeah, right?
No, they can't. We can't put them on a series. See how?
Oh.
Suppose this is one appliance, this is another appliance, this is another appliance, and they both, all of them are connected in series. Now what happens is there is only one source of current, so current will come through this wire only, and it will
Mm-hmm.
pass significantly to the other appliance. Suppose there is a current and it goes through this, and somehow this appliance broke,
Mm-hmm.
or the circuit explodes, or you can say short circuited.
Mm-hmm.
Then these two will not get current, no current for them.
Mm-hmm.
So they are become useless. Are you getting it? Because you have to repair it first, then you can use them.
Mm-hmm.
But in parallel combination, the thing is completely different because if something is explode, or you can say damaged, or it's not working, like this is not working. So all
Mm-hmm.
right, current will not go there, but it will go there and it will go there also. The
Mm-hmm.
circuit is complete. So that's why parallel combination is supposed to be the best. And that's why our houses or anything which is being electrofitted, it is done in that way only. All right. We have to find the current in each branch, assuming that the batteries must be connected to the potential across the resistors must be equal because this is what we learned that in parallel combination potential remains same. So it must be same for 1 ohm resistor and
Mhm.
must be same for 2 ohm resistor. So potential is nothing but IR. So we can write I1 R1 assuming that there must be going I1 current and there must be going I2 current
Mhm.
is equal to I2 R2. So I1 and I2 is something we have to find. What is R1? 1 ohm. I2 is something we have to find. What is R2? 2 ohm. So we found that I1 by I2 is nothing but 2 by 1.
Mhm.
Now we got the value of I1 and I2. Here, such questions can be done through this application thing of current. That if the resistance is more, current will go less. If resistance is less, more current will flow through that wire.
Mhm.
So resistance is less here, like 1 ohm is less than 2 ohm. So the more current will pass through this wire. Because current is something which also wants like less resistance. Why it
Mhm.
wants feel that resistance? It can follow the route which doesn't has that much resistance. So this is what it does. And in order to find it, we actually do is like whatever amount of current is flowing through it through both the wires, it must be anti-proportional to the ratio of their resistances. So like
Mhm.
resistance RA by RB is something 1 is to 2. So more current will pass through 1 and less current will pass through B. And in what ratio? In opposite ratio of the ratio of the resistance, like 2 is to 1. So I1 by I2
Mhm.
would be 2 is to 1. So what we can do is we have to find the value of 2 is to 1 of 6. So 6 must be total and we have to find 2 is to 1 like 66% by 33%.
Mhm.
So 66% of 6 is nothing but 4 and for 2 is it is 33%, it is 2. So the current in each branch would be that I1 is something which is 4 ampere and I2 is something which is 2 ampere.
Mhm.
So this is what we're supposed to learn here. Then again some questions, you can practice them. This is something I need to tell you. This is the special case of the combination which says all resistors are in parallel combination.
Mhm.
Whenever you want to find the R net, it would be 1 by R1 plus 1 by R2 plus 1 by R. Again, you have to find the resistance across AB. So you have to find solve the circuit. So like this is how I can draw this circuit again. Like it's like something like that is there. This is B, this is A. These
Mhm.
are the resistors, which is of 10 ohm, 15 ohm, 20 ohm, and 30 ohm. What is the type of this combination? Like
Mhm.
which combination is this?
Um.
Which combination is this of resistors?
parallel.
I'm asking like which type of combination is this for resistors? Like two are connected in this way. So this is
Mm-hmm.
parallel combination. So here R net for these two would be 15 times 10 by 15 plus 10, like the relation which we saw in the last page.
Mm-hmm.
So if we solve it, we'll get 150 by 25, which is approximately how much? 6. So the net resistance of these two resistors will be 6 ohm only. And if I do it here also, so it would be 30 into 20 by 50, which is approximately 12. So for these combination, it should be this, and for that combination, it should be that.
Mm-hmm.
So here, the net resistance is something. So at last, we can say this is R1, R2. This was 6 ohm, this was 12 ohm, and it is nothing but 6 plus 12. So net resistance would be what? 18 ohms.
Mm-hmm.
Like this is again a very technical thing. Once you review the questions, just give them time because they will take time to get understand. But once you understand them, you find them very easy. Like
Mm-hmm.
all you need to know is the relations, and the relations are very simple. For series and parallel, both combinations, as well as Ohm's law is again very super simple. V is IR.
Mm-hmm.
So you just have to use them, you have to manipulate them, and ultimately you have the answer. That's it. Again, this so this is something which is in parallel. So RP is something 2R into R by 2R plus R. So it would be 2R square by 3R. This is RP. So R will cancel out R. So we'll get the net of these two will be 2R by 3. And something is connected in series as well. So R plus 2R by 3. So it would be what? 5R by 3. That is the net resistance of the circuit.
Mm-hmm.
This is what we have to find. Then again, same. We can try them. This two. This is something we need to discuss. So an important thing. If you saw a circuit like this, so what you can do is you can short this wire. Now, what do we mean by shorting of wire? Like removing this end because it is something which is not going to affect the circuit. So ultimately, suppose if this is a point, this is 30 ohm resistor, and something is connected is 90 ohm, and which is connected is 30 ohm. So this is how the circuit looks. If you short this wire, so you can
Mm-hmm.
easily solve the circuit like this is 30, this is 4, this is in parallel, this is in series, and whatever comes was in parallel with 30 ohm. Then all are in series. So just remember the concept here, you have to short the wire. Then again, it is the same question which we did earlier, like based upon the ratio of I1, I2 is something opposite of R2 by R1. So it should be 4 by 2. So 4 by 2 is something, again the same thing. 66% of 12 should go through 2 ohm, and 33% of 12 would go through 4 ohm. So I1 and I2 can be calculated according to that. So 66% of 12 would be around,
And like almost 8.
hmm, and it is 4. So this is our I1 and this is our I2. And we can say that potential difference V is something which should be I1R or either I2R.
Mm-hmm.
I2R2, I1R1. So I1 is 8, so 8 times 2 is 12. Similarly, let us find V2, like for this resistor also. So it should be 4 times 4, which is again 16. So both are
Mm.
16. So this also proves that our answer is correct because potential across parallel circuits is same.
Mm-hmm.
Same question. You can try this when I share the PPT. Then again, now it become more technical. You have given the values of resistors and the current flowing through the wire, and you have to find the potential drop through 4 ohm resistor, like from this. So what we can do is just solve the circuit. It was 3, it is 6, it is 4. So these two are in parallel. So let us find that parallel combination answer. So it should be 3 times 6 by 3 plus 6, that is 18 by 9, which is 2. So it should be
Mm-hmm.
2 ohm. And this is 4. And there is a battery which is connected, which is of like how much potential. This is what we have to find. And we have given that the current flowing through 3 ohm resistor like this is
Mm-hmm.
0.8. So we just saw in the previous question that if we have the current of this wire and the resistor, we can find the potential, which is 3 into 0.8, which is something 2.4 volt. So 2.4 volt of resistor must be there to across 6 ohm resistor. So 2.4 must be equals to 6 into I2. From here we'll get the value of I2, which is approximately 4 by 10, 2 by 5, 0.4 ampere. So we had I1, now we got I2.
Mm-hmm.
So the total current that is must be going through 4 ohm resistor is going to be I1 plus I2. I1 is going to be 1.2 ampere total current, I1 plus I2. So we got the current. Now we can find out the potential across 4 ohm resistor. The potential
Mm-hmm.
across 4 ohm resistor is going to be 4 times 1.2, which is 4.8 volt only.
Mm.
Whereas the resistance across here is 2.4 volt. We'll add these two values and we'll get the potential of the battery, which is 7, which is 7.2. Did we made a mistake somewhere?
I
We must
think
have made a
so.
mistake somewhere. That's why. Okay. The question asks the potential drop across 4 ohm resistor. यहीं पे बताना है. We just have to tell that what is the potential drop across 4. So it is 4.8. So C would be
Mm.
the correct answer. But if the question would have asked what is the potential of the battery, then the answer is going to be 7.2.
Okay.
So another same type of question, you can try it out. Another question. I have kept a lot of questions in this PPT so that once you're going through this chapter again or this topic again, you can have some questions to practice.
Mm-hmm.
So these are same questions, completely based upon same thing. Now this is an important or different arrangement. So whenever you see that the circuit has resistors put in this way, always remember this configuration or this
Mm-hmm.
configuration is
Mm-hmm.
same, means they are
Mm-hmm.
in parallel combination. So 1 by R net is going to be 1 by 30 plus 1 by 30 plus 1 by 30. That is,
Mm-hmm.
it is 3 by 30. So R net is going to be 10.
1/10.
And there it is 15 ohm. So 10 plus 15 is going to be 25 ohm. That is the R net resistance. And 5 ohm is also there by the battery. So it would be 30 ohm.
Mm.
This will be the net resistance of the system, like whole circuit. Now we have to find the current. No, we have to find the potential drop. For that, we have to find the current. So current is something which is found by Ohm's law. Ohm's law says V is nothing but IR. I is going to be V by R. Potential is there as 3 volt. Like here we have 3 volt. And net resistance we found as 30 ohm.
Mm-hmm.
So current is going to be 0.1 ampere only.
Mm-hmm.
So current is going to be 0.1 ampere only. And we know that the net resistance of this thing is 10 ohm. So potential across this is I times R 0.1 times 10. That is 1 volt only. So this is our
Mm-hmm.
answer. Is it clear?
Yeah.
Again, there are some questions. If there is something I should explain, I should. But the rest of the questions are something which you can try as a part of the homework. Whenever it
Mm-hmm.
feels like that there is some difficulty in getting the answer, just ask me.
Okay.
And it's better that you should try them as soon as possible, because if you
Mm-hmm.
try them as soon as possible, it will be there when you are revising them.
Yeah.
That is something I should advise.
Okay.